Morning meetings are over. It's time to start doing our job, which is coding. What a developer's environment, their desktop or laptop, looks like is very personal. People can do whatever they want and choose to. What I'm showing here is the average configuration I like to use, which is the 2-monitor setup, in which I have all sorts of these tools here. This is important to understand a little bit about what each of these do because they'll be referenced and talked about in a lot of status updates and just general conversations. Starting with the Integrated Development Environment, or IDE, is a tool in which a developer is able to write code as a part of some individual application, and this environment will automatically compile it and check it and run the application for them, along with including all sorts of tools and plugin behavior. The next most important developer tool is your web browser. Why? Because we have to Google a lot of stuff, or on Stack Overflow. It's important to understand that technology has become so broad, an individual job role may require something like 40 different technology specializations, at which no one's going to have them all. So no matter how experienced you are, you're always going to be having to learn something new on a given development project. So that means being able to access the internet for looking up information, and plus looking at other tools like diagrams in your work tracking system, are an important part of being able to code. Next we have the shell, which is the command line. This is an essential tool for developers because sometimes the IDE doesn't have the ability to run the build within it, and also there's just some things you can more easily do at the command line for exploring. And then finally, we're going to have some sort of messaging system. In the days of remote work, the way in which we stay in contact with our coworkers is going to be via instant messaging, whether it's Slack or Teams or something else. We always have some sort of messaging platform, sometimes multiple, running so that we can talk and ask questions and just coordinate because we're not there in person. So back to our problem space. I'm developer 2. I'm working on this REST template thing. So the first step I really need to do is figure out what needs to change. And so in my IDE, I pull up the code in question, which in this case, it's just pseudocode, a piece of code representing, hey, we're using REST template. I don't want to use REST template. I want to replace it with something that's not a performance bottleneck. How about OK HTTP? And so they're going to go on the internet, since they don't have much experience with this technology, and they're just going to search, how do I build a request using this technology? They find an example, and they kind of plan out in their head, okay, this REST template code is used in these 5 or 6 places. I want to replace it. So I know what needs to change, but am I ready to change it? Before making the code changes, though, we need to understand what the impacts are. So this helps to use a diagramming tool, whether Lucidchart or Draw.io, which is free, to visually notate how what we're changing impacts the application from a feature perspective. In our case, working back, we're going to start with the URL utility. This is the underlying code that is used to do the communication with the other services. So in our case, there's multiple calls, more calls than I can count that are going out. But then we go in the code base and search for, in the back end, what places are using this URL utility. And I find that it's these 3 services. And with these 3 services, this is within the service layer of the application. And so they're involving getting price, getting images, and getting in-stock information. Now, these services aren't used directly. They themselves are used by controllers inside of a very common MVC-style pattern for backend applications. And these controllers are what the front end, notated as V, are actually using to get the price, get the image, and get the in-stock information. So in the case of my implications, I know that I'm changing the underlying functionality for getting price, getting images, and getting in stock. And so I need to be cognizant of how my changes are going to impact those 3 endpoints from an integration testing perspective. This gets into the most important question. How do I test it? So I know what the impacts are, so I'm going to start with my integration test. I have integration tests for getting the price, getting images, and getting in stock. So I know, at least from a standalone code perspective, that I'm not going to break the code level behavior. However, this is an integration level issue, meaning our system's having to reach out and communicate with another system. And so I'm going to need to have some type of acceptance or regression level testing behavior after I make my code changes to verify how this works. That means I need to actually run my application and have it talk with a third-party service in question. And that's where, if I'm using a modern application for RESTful services, I can, in my web browser, open up an application page that is a list of all of my individual endpoints so that I can click on them and use them to manually invoke the endpoints for my application, which involve calling the endpoints of another application. So I know that I'm going to have to do some integration test updates, and I know I'm going to have to manually verify it by invoking the endpoints for price, images, and stock. Now it's time to make the changes. And so this is the place where I come in and I start with my test. I always like to take my test case and change them around first to figure out what the inputs and outputs are, especially when I'm dealing with framework level behaviors. So I come in, I work out what the test case is, I make my code change, I ensure my integration test pass. Okay, so my code's consistent and behaves well, and I meet all my standards. Now it's time to start up my application, go to that OpenAPI definition page, and manually invoke the endpoints for getting price, getting images, and getting in stock. When I see that they're behaving the same way as I'm running my application locally, I'm good to go. I've been able to make this code change, and it's working appropriately, not using REST template anymore. The next step is taking the code changes which I have locally and pushing them to a central location, which will trigger automation for building and verifying and doing other stuff. And so before I do that, though, I want to use whatever my build technology is to run my local build process. This is critical for modern software applications, that before I commit any of my code to a central and shared location, I can run a process locally which runs my unit tests, runs my integration tests, generates reports like code coverage and for static code analysis, and also that they're enforced. And so what I'm doing is, now that I've made my code change, I've verified it manually, I've updated tests for it, I'm getting ready to prepare it, I run local validation to ensure that everything's working, everything's green, and then I see that I've had to change the get price test, the get image test, the get in stock test. I change the REST utility class and I change the test for it, and I push that change to a central location. Now, in any modern software development, whenever you make a change to any given code base, according to CI principles, those principles being I try to change stuff at least once per day on the main branch. Whenever I make a change, it triggers an automated build and test, which is what's now happening in Monitor 2. And then if it were to fail, I'm going to fix it within 15 minutes. And so in step 2, by me pushing that change, this pipeline technology, we'll call it our continuous integration technology, runs the check stage, which is running all of our static code analysis and code formatters. It'll run a test stage, which runs all of my unit integration test, and then it will run the build to verify that the application code base fully works according to all its tests. At the same time, it's also very popular to connect whatever your CI technology is to your messaging technology. So you can see on the lower right, whenever this happened, I got a message in chat on the DevOps channel saying, hey, at 11 a.m., user John committed a pull request and it's now running as pipeline 456.